Hey everybody, this is the notes for 1.1. We have some definitions here at the top, so if you could write them down. First one's algebraic expression, and the second one's numerical expression. And as you're doing this video, you can pause and play it, whenever you feel you need to. So, don't try to stay with me too much if I'm going too fast, and just hit pause, finish up your notes, hit that play, and get back to where I'm at. Okay, so an algebraic expression is numbers and or variables that add, subtract, multiply, or are divided. So that might be something that might look like this. I've got I'll have a number and a variable, so that really says 2 times x and plus 1. So that's a algebraic expression. I can't really get an answer for that unless I actually put something in for x. Okay. A numerical expression is going to be numbers that are just added, subtracted, multiplied, or divided. Okay. So you might get something that's kind of like this. Okay, so in this case, I go 6 minus 2 is 4. And 4 minus 2, or 4 divided by 2 gives me 2. So in a numerical expression, I can sometimes get a real answer. Okay, so a little bit of difference between what algebraic means and numerical means. Just means in algebraic expressions, you're going to have a variable in it for sure. Okay. All right, now we need to learn as we go through this year in math that we have to get a word problem. We're going to have to once in a while write out an expression or an equation to represent what the word problem says. Okay, so a couple of things here. When you see the term more than or less than, it means to flip the order, okay, of how this is written. So in this case, the first one, I'm going to flip these two guys. I'm going to flip their order. Now, more than to me also means that I should probably add. So if I'm going to flip the order, x is going to come first. I'm going to add it to 32. So I should get something that looks like that. Okay. So next one, 58 less than a number y. Well, if I see less than, it tells me flip it. And less than really to me means I should subtract. So I'm going to flip the order and subtract it. So y would come first, minus 58. Now that's really important when you're subtracting, because if I left it like that, let's just say that y equals 0. Let's just say I'm going to put that in. Okay. If I put 0 in for y right here, I'm going to get a negative 58. Okay. But if I hadn't flipped it, I hadn't flipped the order like I was supposed to, and I still put 0 in for y, I would get that, and now I get a positive 58. Well, that's two different answers, and getting the right answer is the most important thing. So we have to remember that when we see these two terms in your head, you gotta go, okay, flip the order. All right. So 12 less than the number p, I want to flip the order. Less means I want to subtract, and I think I get p minus 12. Okay. All right. When I have word problems, and in this case I'm multiplying or dividing, okay, 8 times the number m. So when I have that, mathematicians in the old days, they used to write it out like this. They used an x as a multiplication sign. Well, in algebra now we use x as a variable, so we don't want to get messed up. So then mathematicians started just using a little point to say, hey, multiply those two things together. And then, mathematicians are kind of lazy. So they ended up just kind of, when they stuck two things together, especially in this case, a number and a variable, that says to multiply. Okay. So these two things are the kind of more acceptable ways to write multiplication now in algebra. Okay. All right. The quotient. Quotient means to divide. So quotient is really a answer to a division problem. Okay. So the quotient of a number y and 5, I could just go ahead and write y divided by 5. Okay. But mathematicians kind of got lazy, and also, you know, when you do some other kind of math, a fraction also is a division problem, and I could turn that fraction into a decimal number so that I do that by division. So another way to write that is in fraction form, so y over 5. Either way, it's okay. I want you guys to remember that this is division right here, and you'll see it a lot that way. Okay. All right. So we're going to take these first kind of sets of notes here, and we're going to kind of put them together and write one big algebraic expression. The other thing too, just as you're going through taking notes, best thing to do is, if you're not really getting something, doesn't make sense, you know, I'm assuming you're using these when I'm not with you. So somehow circle it, or put in a box, put a star next to it, whatever. Ask Mr. Kasnick, you know, I didn't get that. Can you go over it with me the next time we can see each other? Okay. Okay, 3 more than twice the number. Right now, more than tells me to flip. Okay. 3 more than, I'm going to add 3. Now, this one, twice the number, really means I want to double it. So really, I want to, in this case, multiply it by 2. Okay. So if I'm going to take all that into account and write an algebraic expression, I should get 2 times x plus 3. Okay. All right. 9 less than a number. So in my head, 9 less means to go ahead and flip it. Okay. We got the word quotient means to divide. I'm going to take the quotient of a number of 6 and a number. So I'm going to take 6 divided by v, and less than 9. So I'm going to go subtract 9. Okay. Now remember, I can rewrite this as a fraction. Okay, so that's kind of what we did here with you guys. We took that division problem and we put it as a fraction. So either way you want, you can do it whatever's most comfortable for you. And sometimes too, you might see this in parentheses. Okay, it doesn't have to be, but sometimes, you know, like the book will do it for you, or it's on a test like that. Okay, same thing. All right, next one. They want us to write this out. So I'm going to go ahead. You can write these out a lot. I'm just a lot differently. I could write it one way. You could write it one way. It might still mean the same thing. Okay. I'm just going to do it really easy. I know this is multiplication, and so it's 3 times x. Okay. I could write it like that. I'm just going to write this one as the way I see it, but I'll do it another way. I'm going to go y plus 8.1. Some people get fancier. The sum means the answer to addition of y and 8.1. Okay, or we could do it like they were kind of doing it to us. We could use that more than, less than. So remember to flip it. So 8.1 more than y. Okay, all 3 of those are correct. Okay, now this one's a little bit trickier because I got some multiplication here and I'm going to have to subtract. But I'm going to write out the easy way. I'm going to go 10 times d minus 6. Okay. Now, if I want to go that fancy way that we kind of did earlier, I would flip the order. So I'm going to go 6, and I was subtracting, so less than. And I'm going to use the word product. Product means the answer to multiplication. 6 less than the product of 10 and a number D. Okay, now I said the number D. D is a variable, but remember I can put numbers in for the variable D, so that's why I use that term. Okay, so either way, those would be okay. Okay, so we've got this student over here building a house of cards. I know it looks like cards on the ground, but up on the table it kind of looks like blocks. So you can call it blocks or cards, whatever you want. I'm calling them blocks just because on the table that's what it looks like. But anyways, the student is building different levels of this house, building it on the table. So there's a couple things we need to know. First off, that the table is 24 inches tall. And that's represented in this rule that they got going over here. This is called a constant. Okay, it doesn't change. It's the same all the time. Okay. The other thing that's a constant is the card or the blocks, whatever you want to call it. They are always 3.5. Okay. And so each level is going to be the same height, but as I add levels, this whole thing is going to change heights. Okay. So let's kind of do some math together here. I've got 2 levels, so that's where this 2 comes in from. Okay. So 2 times 3.5 is 7. And then 7 plus 24, or the table, gives me 31. Okay, so I built that. Now I'm going to put another level on it. How tall is it going to be? Well, now it's the 3rd level. Okay, so 3 times 3.5 gives me 10.5. And 10.5 plus the table gives me 34.5. Okay, all right. Then the next one, I build another level, the student does, and that's now level number 4. 4 times 3.5 is 14, and 14 plus 24 gives me 38. Okay, so it's 38 inches tall with the 4th level. And if you guys notice, the answers between all 3 of these is 3.5. Well, where is that? Well, that's represented by the height of the card or the block, whatever you want to call that. So it should be changing by that much each time. Okay, so that's it. If you're ever a carpenter or you're a contractor and you're building stuff and you need to figure out how many boards do I need, and then will the boards do this or that, that's kind of something you would use to help you figure out how much you actually need. Okay. So to write the actual rule is the height of the card or the block times the number of levels. So they use the letter N for number of levels plus the table. That's what makes the height all the time. So I could say, you know, how tall is it going to be when I have 15 levels? Well, I stick 15 in for N. I could do some math and I got my answer. Okay. So writing the rule as an algebraic expression to finish that, it'd be, I just go 3.5 times N plus 24. That would be just the easiest way to write it. There's a couple other ways we could do that, but let's not get crazy, okay? So how tall would the tower be if there were 10 levels? Well, that means I could take that 10 and put it in for N, still adding it to 24, okay? So I can go 10 times 3.5, so that would give me 35. 35 plus 24 would give me 59. Okay. Now what they want to know is, what would the rule look like if the card was 5 inches tall? Well, when the card was 3.5 inches tall, that was it, okay? Well, the card's changing. Now it's going to be 5 inches tall. What do I do? Well, I need to change that, okay? It didn't say anything about the table, so I'm going to leave that alone. N still represents the number of levels, so I'm going to get 5 now, N plus 24. Okay. So that's how you take kind of some words and put it into numbers and variables in this case too. Okay. All right. So if you got any questions, make sure you get a hold of me and we can go over stuff and make sure that those notes get turned in when you can.